Yeah, this is what meet and greet translates to in the digital space. It's awkward silence while we wait for people to join.
Well, I can start by kicking off a little small topic while we wait, if anybody's up to it. What does anybody have a prediction for 21 regarding JS? What will be the next thing? What will be the biggest thing in this year?
Good one.
And can we pass the ball around and people can come with their ideas? David, would you want to start?
I think Joel predicted this is the year where Svelte goes really big, right, Joel?
Well,
I hope so, at least.
I'd say so.
Just take a week in our jobs and just convert our React applications to Svelte sometime this year, maybe during the summer when nobody's looking.
You don't need to convert everything, right? We could start taking out chunks, right? It doesn't need to be a total rewrite.
Can you even do Svelte partially, or it seems like you have to compile Svelte files to JavaScript?
Yeah, of course, but I mean, there's nothing stopping you sideloading it, right? So you could have a running application and then parts of it in Svelte, so to speak.
Have you seen the thing about the Webpack where they talk about the federal modules? I think it's called that. Where you can you don't need packages anymore, but you just do like a denote or node, or not denote, where you import it via URL, and then you get all of these things, and then you can sort of mix match everything, like some React part and some Svelte part and some Vue. It looks crazy.
I think David knows, but he has to kill you before can tell anything about it.
Okay. What it's called? It's called federal modules or something like that. Is that the name?
Federated modules.
Federated modules. Yeah, that's it.
They've had it for a while, right?
Yeah.
It does seem like the way to go. Yeah, it feels like stuff is moving in that direction in general with Deno, as you said, and other stuff. Yeah. Yeah, I'm very curious what 2021 will bring.
But one thing I don't understand is how do you do the continuous integration on it?
The whole concept blows my mind. I mean, what about CI? What about, it's such a different way to approach things.
Yeah.
Yeah. We'll see when the dust settles, I guess.
Yeah.
I also guess we should get this show on the road. Welcome, those of you who made it here, to another digital session of MalmöJS, the third, I think. I'm looking at your square now, Johan, to correct me if I'm wrong.
Something like that, yeah.
So we've been, earlier we've of course been doing regular meetups in the Malmö area regarding JavaScript. We are slowly transitioning into the digital space, and it feels like we've picked up the pace a fair bit. So in a couple of months ago, Marco was doing a talk on having your dev environment in the cloud.
Yeah, about a month ago, right?
Yeah. And today we're going to talk about Redux alternatives. Johan, being the king of MalmöJS, do you want to say something more eloquent about MalmöJS?
Well, I'm not sure if I'm the king. I think it's more of a democracy
Republic.
than that. But yeah, I mean, glad to see so many people have joined. It's going to be interesting.
And we don't have an upcoming meetup scheduled yet. There are some ideas in the works. If any of you guys have something you like to share or ideas on something you want to hear more about, then please reach out to us. Either here directly, or there is a Slack user group. Please just ping us if you want to join. And with that, I give the microphone and the power to the first speaker for tonight, Mark Klefter. Take it away.
Thank you, David. I sort of feel like I should be having a He-Man background or something.
You should, yes.
Let's see, share screen. So there we go. Hi, everybody. Thanks for tuning into this talk. My name is Mark, and I work as a tech lead at a company called Edumelt. And feel free to reach out to me after the talk. I'll also be posting the sample code on GitHub, so I'll provide you with the link later on, David. So this talk, or as has been described by David in his intro, was or is supposed to be an introduction to using XState as a state management solution, sort of a Redux alternative. And the XState library can be viewed this way. But I've titled my talk, as you can observe, as Modeling Application Behavior in React with XState. And the reason is that I have a somewhat loftier goal in mind with this talk, and that is to promote XState, the library, as a way to embrace a degree of formalism that we can utilize when we build front-end apps. And so maybe perhaps the obvious question is, what do I mean by modeling behavior in an app? Are we talking about UML diagrams or something similar? I would say that yes, certain patterns and visual tools or aids are part of this sort of formalism that we are able to use with UML. But to provide a bit more of a background, in my latest project, I had the pleasure, some would say misfortune, of building a WebRTC app where we had web clients interacting with users wearing augmented reality devices. We had a lot of interaction occurring in real time. And long story short, we ended up with a large amount of complexity in our app logic, to the point where we needed to really take a step back and figure out what is going on in our app. How do we properly model everything? Because it was quickly becoming overwhelming. And it was especially important to ensure correctness and robustness in the app, as it was targeted towards the medical community, which has very stringent requirements. So an interesting observation that we made, and I guess everyone in this call typically makes, is that I would wager that pretty much every single app that we build is or comprises some state machine or state machines, whether we know it or not. I think that's why they're so prevalent in almost all types of software. We have states, we have events pretty much all the time, but we typically don't always model these constructs with explicit state machines, but they are prevalent, they are there, sort of informally, implicitly. And that's actually what we had in our project. We had a multitude of application states and events. And of course, we had data that was to be shared among different parts of the app. So what it boiled down to was the following objective: ensure that certain things, often bad things, do not occur if the app is in a certain state, in a given state. So that's perhaps a very basic objective or goal, but it turns out to be harder than you might realize as the complexity in your app grows. It becomes quite hard to realize unless you turn to something more formal. Now, since we already identified a lot of states and a lot of events in our app, the natural thing to turn to was, of course, state machines. So to just recap quickly what a state machine is, or finite state machine is, it's a mathematical abstraction or representation of how state changes over time. And there are a few properties that are relevant to this discussion. State machines have an initial state that the machine is in. It has a finite number of states and also a finite number of events. And these events trigger transitions between states. And this mapping of one state to another due to some event being triggered is also part of the machine. And there's also a sort of complementary system to state machines called state charts. And they can be sort of thought of as a set of abstractions for modeling stateful reactive systems. I tend to think of them as extensions to state machines. Both finite state machines and state charts are things that are implemented by the XState library. And that's what we're going to utilize in the sample app. Again, the objective is to ensure that our app behaves correctly, what we deem correctly, when it's in a certain state. Some quick terminology just to also differentiate between what I'm talking about and how it relates to Redux. When we talk about state in Redux, we're typically talking about managing globally shared data. State in XState, however, is the actual condition, state or condition, that our app is in at any given moment. And additionally, our state machine can have associated data, contextual data that is relevant to the machine. And this data is sort of not exactly an equivalent, but close to the equivalent of state in Redux. So state in Redux and state in XState are distinct concepts. To illustrate XState, I wanted to model a task executor, something that we can provide a task as an input with, for example, a task for fetching data, and then go through various stages to either get a result if the task is successful, or an error if there is a failure. So we'll have a few states. We'll have an idle, pending, success, and failure states. And we'll have events that will transition or lead to transition between those states. We'll have something called execute, cancel, done, and error. And we'll use these states and these events to construct a state machine. I'll also be drawing comparisons where appropriate with Redux along the way. So, state machine in XState. To help us build it, we can utilize the so-called XState visualizer. This is one of the coolest thing about XState. When we model our state machine, we're presented with a tool that immediately reflects what the machine looks like and allows us to interact with it to sort of test drive our machine. And as we'll see, as we build out our machine, our visual representation will be built out. And this is not only good for us as developers, it's only something I realized, it's also something very useful for other stakeholders in a project. Even people not typically developers are very fond of being able to view from a sort of a higher level how the app works, and actually test drive the app as well through this representation of state machine. So I've started out a very simple machine in XState, which has an ID of task. So we provide it or identified by an ID. A state machine has an initial state. So we say that our initial state in this machine is idle. We have a context, and this context is this globally or data that is to be shared among many parts of our app. That is sort of the connection to Redux. So context in our case will be data that can be shared among multiple components, for example, in React. And I'll be adding what we need in our context for our machine to perform. So I'll add a value, which will be the result of our task successfully completing, and an error in case we get an error when the task fails. So this is our state in terms of Redux, if we use the Redux terms. And then we have states, all the various states that our machine can be in. So we have the idle state, which is also our initial default state. We'll specify that if you're in the idle state and an execute event occurs, we'll transition to pending. So we declare that our idle state has a transition to the pending state given an execute event. And from the idle state, we can enter the pending state. Execute pending state. And there are a few things we can specify while in the pending state. I'll start off with the events that can occur while in the pending state. And that's cancel. We'll be able to cancel a task. If we cancel a task, we'll simply transition back to idle. And the remaining states are success. When a task completes, we'll enter a success state. And if we're on success or in success and also receive an execute event, we'll transition to pending. And the same will be true for the failure state. So if I update my visual representation of this machine, you'll have a pretty clear picture of the various states and the events that lead to transitions. So while in the idle state and the execute event occurs, I'll transition to pending, from which I can cancel to go back to idle. But there are a few things remaining to bind the pending state to the success and failure states. But these are our states, all of our states in the machine. So I want to particularly mention that if you view this as sort of a switch statement, notice that we're switching on the state we're in first, and then we're considering the event that we're supposed to work with. If you compare this to a reducer in Redux, we're always switching on the action type, which sort of can be compared to an event here. We're switching on the action. We're not switching on the action and the state we're currently in. But here we always start off, what state are we in? What event or action do we receive? And then we transition. So we have more information to work with in XState than we do in Redux. All right, we have a few things missing, and those are so-called side effects. So side effects come in various shapes, but they're typically some sort of consequence of entering, exiting, or transitioning between events. So for example, one action we can take when entering the pending state is to say that upon entry to the state, we want to reset the context. So if we already executed a task beforehand, we want to reset the context because we're performing a new task. So I'll leave the implementation of reset for now, but just notice that upon entry to the pending state, we're resetting the context. Now, this is a synchronous action. So simply resetting the context is a synchronous process. There are other types of actions that are, or side effects that are asynchronous in nature. And such actions or side effects are invoked using XState terminology. So if we actually want to perform an asynchronous task, we invoke it. And here I'm also going to just be referring to something I call a task executor, the actual thing that will execute a task. Let's see. Thank you. And asynchronous actions have two events or react to two events, on done and on error. And there are a lot of different ways to implement these types of asynchronous side effects or actions. I'll be using observables, but you can use promises, regular callbacks, and even other machines. But I'll use observables in this sample app. So upon completing this asynchronous action, I'll say that I want to transition to a target state of success. And as part of this transition, I also want to perform some extra logic. I'll call that handle success. And if my asynchronous action completes with an error, I'll say that my next state would be the failure state. And the action or actions I want to take upon that is to handle failure. And with that, I can simply add the implementations for these reset, handle success, and handle failure actions. And I'll put them at the end here. So I'll add another object or parameter to my machine call. And here I'll specify the actions. And as you can see, the reset action is a synchronous action with simply using something called assign from XState, simply resets the value and error. Handle success receives an event, which will be this on done event. And this is where I will update whatever the value is supposed to be. And when I get a failure, my error field will be whatever the event provides me with. So they look alike, and that's because we handle the results from handle success and handle failures pretty much the same way. It's just a field in our context that is separating them. But these are so-called synchronous actions. We simply update machine using these actions. The action that we invoke, which we refer to as something called task executor, has not yet been specified. I'll do that shortly. But this is the entirety of my state machine. If I update my machine, you'll have the complete picture of what the app has to work with and the various states and events that are present. So if we start off, we are using this task machine to model a task executor. We start out in the idle state. And if we receive an execute event from somewhere externally, we'll enter the pending state, where we reset the context. We reset the value of, well, value and error upon entering this state. And here we have different choices. We can cancel the event, cancel the task, which will bring us back to idle. We can receive a done event from our asynchronous action. And if we do that, we'll enter the success state with an updated value. And from here, we can execute a new task, enter the pending state. But perhaps this time, the task results in failure. So we get an error event, which will bring us to the failure state, from which we can also, again, execute a new task, bring us back to pending. If we cancel that one, we come back to the original initial state. So this declarative description of my machine, along with this visual representation, is something pretty useful to navigate the various idiosyncrasies in your app, and proved in our latest project to be a very positive thing for other stakeholders as a way to look at. So one more thing I want to mention that relates to Redux. Redux in itself is a state container and state container only. We leave all types of side effects to what we call middleware, where we can choose from various libraries like Redux Thunk, Redux Observable, Redux Saga, and so on. In XState and state machines, in the way XState has implemented them, side effects are part of the machine description. It's not something we elect after the fact, after we have constructed our Redux store, for example. This is part of the machine. And there are various schools of thought on this. I sort of become convinced that side effects should not be an afterthought, something that is introduced later. They should be treated as first-class citizens in your app logic, which XState allows us to do. This provides more guarantees for us to ensure correctness, robustness, and so on. Furthermore, this state machine does not distinguish between synchronous and asynchronous data flows. There is no difference. What do I mean by that? Well, if you take Redux Thunk, for example, the way you use Redux Thunk for asynchronous data flows and the action creators you implement look a bit different from regular synchronous action creators, right? That distinction does not appear when using state machines. You have events and you have state transitions, and that's it. You can have various types of actions, of course. This invoked action is asynchronous in nature. This reset action is synchronous in nature, but all of them are part of the machine and declared pretty much the same way. So this was the declarative part of using state machines. Again, very useful to get a bird's eye view of the behavior of my app. And this is the way we model, model the behavior of the app or the UI that we implement. So the thing that is left is to basically copy paste this into a React app and start using it within our app. So I'm going to simply copy paste all of this and bring it into my app. So this is, I think, pretty neat. Declare it in the visualizer, copy paste it pretty much verbatim into your project and then start using it. So how do we actually begin using it in a component? Well, we have a helpful hook for that purpose. And that hook is called useMachine, appropriately enough. And this hook accepts a machine object. And this is also the place where I'll be implementing the actual task executor using observables. So I'll extend the machine description by adding something called services. And I know that in my machine description, I refer to this service as the task executor. So I'll add a task executor field in my services object. I'll declare it as the return value from a function that gives me the current context in the machine, as well as the event that led to this task executor being invoked. And so I'm using observables. So I'm assuming I get a request from my event, and I'm simply going to be typing the results to or through a map operator, which will send an event back to the machine and say that this action is now complete. This is a bit of a XState detail, but I'm basically sending, given what I complete my request, which is fetching data, when I complete, I create and send an event called a done back to my machine. And that's when I end up in this part. On the onDone event, I'll transition to success and execute an action called handle success. It's a bit of a detail. I'll also set DevTools to true. So I'll be able to inspect what's happening in DevTools when using this machine. Furthermore, I'm going to add the following code to my render outputs. So notice that my useMachine hook returns something called a state object, representing the current overall state of my machine, as well as a function to send events to the machine. Sort of like using useState, the useState hook. And this state object allows me to match on the various states that my machine can be in. So if my state matches pending, I'll simply display a loading indicator. If my current state matches failure, I'll provide a failure message. And if my state matches success, I'll print out the name of a user that I fetched. So this is the output that I can display thanks to my machine being in a certain state. So let's send something to my machine. Let's send an execute event to my machine and provide a request field. I'll simply be providing the URL of the user I want to fetch. So there is my URL. So if everything works correctly now, I'll be able to send the execute event to my machine. It will transition to pending, start fetching my user. When I'm done fetching my user, I'll update the machine and re-render app component and match on the success state and thereby display the current user's name. So let's kick this off. So here's my simple UI. I'll fetch the user. That happened quite quickly, so I'll simply bring that down. Fetch user. Seems to work. Fetch a second user. Also works. And here, thanks to my XState DevTools extension, I have my state machine present with everything my context or my shared global data contains. So right now, I'm obviously in the success state. And if I click fetch user, you'll see down here a transition being made to pending, and then back to success. So it's sort of using Redux DevTools to see actions and the current state, but I'm actually able to follow along all the transitions that occur due to events being triggered. So let's try canceling a task as well. That's simple. I'm simply going to send a cancel event to my machine upon clicking the cancel button. So now if I try to fetch a user and I cancel, obviously my fetch got canceled. And then beauty of using observables is that they have sort of an automatic canceling behavior built in. You can unsubscribe some from an observable. So that made my code a bit easier to write. You can do this with promises as well, but it's a bit clunkier. So seems to work well. What happens if we try to fetch a user and click the button several times for the same ID? Do you notice that I'm prohibited from fetching the same user concurrently? And that's because my state has prevented, or my state machine prevents this from happening. There is no way for me to trigger execute while I'm in the pending state. That's not part of it. So even though I try to fetch a user multiple times with the same ID, it's prohibited by my machine. I've modeled it that way. So it cannot happen. So impossible state transitions are just that, made impossible by my current machine. And this is actually the way we want to work with this type of logic. I've seen a lot of projects where we prohibit fetching something by simply disabling the button while we're fetching something. But that's sort of shifting responsibility to a button. This should be built-in stuff in our central logic for fetching something. It should not be left up to a button to be disabled. This works whether or not the button is disabled, because our model for our software, for our app, prevents it. So yeah, maybe you can trigger a failure state by a bad URL. So if I try to fetch a user, that's not going to work. So we're handling that case as well. Let's see if we can get our state machine displayed. There we go. Try to fetch the user, fails. And we get the complete Ajax error in our context to use. So to summarize, I would say that using state machines, especially when your logic in your app grows in complexity, whether you want it or not, but especially as you're dealing with a multitude of states, a multitude of events, sort of implicitly, they just appear or grow in size. That's a sort of a hint that a more formal modeling approach might be useful. And if that's the case, you have XState as a solution, which allows you to declare a state machine to model the behavior of your app. You have a visual representation to work with as well, also shareable with other stakeholders in your project who probably appreciate having this to look at than just your code. Then you copy paste basically the declaration of your state machine into your app, pretty much verbatim, and then utilize the bindings that XState provides for you if you're using React, such as this use machine hook, and actually implement or provide the specific stuff. In this case, our task is to fetch data as an extension to your machine. And then it's so simply a matter of sending events to your machine and matching on what state your machine is in right now. If you follow this approach and you actually take the time to plan ahead, which is sort of the, if you see it as a downside with XState, you have to put a little bit more effort and time before you actually get down to your implementation to make sure you gather all the requirements and model them appropriately in the XState visualizer. But given that, you will have much easier time to ensure that your app behaves appropriately or as intended using very simple constructs. There are a few more things that I haven't talked about XState, but I guess that's a bit outside the scope for this talk, which is more of an introduction and motivation for embracing XState. But again, this is not, I don't see it as a direct replacement for Redux, even though you can certainly view it that way. It's sort of a part of the package that you get a replacement for Redux, but my focus is more on the modeling aspect of this. And that's what's proven most useful for me. And that's, I guess, the big takeaway from this talk. And with that, I am finished. And I'll put this sample app up for you to peruse on your own time. I guess David will share the link to everybody. Okay,
Indeed we
thank
will.
you very much.
Thank you, Mark.
Do we have some few minutes for questions?
Really... We absolutely do. That was an excellent, that was an excellent presentation. And your sentence about how Redux really is the context in XState, that's sentence made things fall into place for me. So the state in the state machine is just sort of implicit in a normal Redux app.
Yeah, the simple comparison I always make is if you model a car, a few states related to your car. It could be that your car is in a state of reverse, parked, or drive. Those are distinct, discrete states. But the amount of gas in the tank is a more continuous, extended state. That's actually the Redux state, or globally shared data.
Mm.
Yeah.
So how would you model? Would you have, is it like one machine per app, or do you have one machine per, subpage? Let's say in a Redux app where you have 10 slices, you have user, project, and I don't know, certain different other parts of the app. Is that one machine with, or how do you think?
The XState actually provides for hierarchical machines, and that's pretty useful. So again, going back to my WebRTC app, I had sort of an overarching state machine handling connectivity and the UI that goes with that. But when you, for example, enter a session with users, the app logic related to just managing a session and the UI that goes along with that required a separate child machine. So you have one parent machine and you have a child machine that handled that part of the UI and that sort of page explicitly. And this is just to make your life easier, basically. And those machines communicate just like my task executor communicated with the machine, sending events back and forth.
That's cool. Thanks.
Beautiful. How would, if you have then sub machines or child machines, so to speak, how would you, can you model them as well? Use your this modeling software or rendering to view them, and how would they look then?
Yeah, that's a good mental note to myself to actually include it in the next time I make this presentation. But yeah, this view would be extended, so you'll have this overarching machine connected to child machines, and you would see this in this view. So if you were to enter a state of, say in my previous project, of connected, and you're waiting for a call to commence, and that call, everything related to a call is managed by separate machines, you would then transition from some state in this machine over to an initial state in the child machine. And you would see this transition occur in this view. And when that call ends, that machine would be sort of removed or disabled, and you would go back to some state in this parent machine. But all of this can be traced throughout the visualizer.
Interesting. So you can basically, you can have different level of abstractions of your machines then, so to speak. So you can have an overarching machine, which is then sub-control with sub-machines, so to speak.
Yeah, to better
modeling.
scope your logic and all the different states that your app can be in. Yeah, and I haven't even mentioned, but if states can be nested. States can be sort of complicated sometimes. So you may have to nest or have hierarchical states, not state machines. But a certain state can have, if you have a type word processing software and you're in editing mode, you can have a, you can be underlined and bold at the same time, for example, to a sort of nested states. So different ways to model things, but there are, XState gives you a lot of flexibility to determine what level of detail you desire to make sense of your app. But having multiple machines is a very typical way to approach modeling your app.
Cool.
And even in this tiny example, it makes sense, right? You are benefiting from using this abstraction.
Yeah, I just love visual stuff. I mean, if there's something that makes me more proficient or efficient as a developer, hit me with it. And this is one of those. I've had many good experiences, let's just put it mildly, using this this tool when modeling something as complex as a WebRTC, for example. But even in this example, it's
sorry. So
you get sort of,
if it's up to you and you're starting a new project, would you ever reach for Redux, or is this your go-to thing now?
I should be honest, I haven't reached for Redux at all for a couple of years now. But I would sort of embrace XState if I have an inkling of my app having multiple states that I'm eventually going to have to deal with. They might not be implemented initially, but they're going to show up, and I need to prepare for it. And I rather much take the time to actually model my app and list the requirements and feel safe in from my starting point when I actually enter my implementation phase. So
it's where you start anyway, right? These are your whiteboard scribblings on the very first meeting. Only now you do it in a JSON form, and it will actually define the behavior of the app.
Yeah, it kind of makes it you don't need to go into the nitty-gritty code to see where you've done some logical error. Oh, well, why does it do this here? Oh, well, it's actually because of this. So to speak, I can really see the usefulness.
Yeah, I basically I gave the client this definition, the state machine definition, and they played around with it, and they themselves came up with states and events that we hadn't thought of.
Oh,
because
nice.
they could see that there's something missing. So our client, that's not skilled in any way as a developer, they were able to figure out things for us and come back to us and say, I think there's a state missing. Have you thought about it? It's like, that's true. Thank you.
That's brilliant.
Wow, that's a powerful anecdote. Yeah. Huh.
And I also guess that you can add a sort of GUI so they can drag and drop some items to it and actually build the JSON, even though if they're not skilled within that area.
Turns out that JSON is pretty user-friendly. They actually were able to tinker with this one themselves, which was surprising. But yeah, it's like easy digestible stuff. So it was exciting to see the type of things happening between the client and us via this tool and this definition. That was pretty cool.
It was a very nice presentation. I have one question that always triggers me when dealing with state, is the question about where does the state live? Does it live on the back end or does it live on the front end? And how well do you sync that between them with the business logic and so forth? So could you elaborate a little bit more about how you sort of solve that issue of doing that? Because I could also imagine that sometimes the backend provide you with these states that they can be in, and then you have to implement that on the front end. And these, the worst thing is always keeping those two in sync with each other.
I would say actually that the modeling occurred entirely on the front end. Our main concern was making the web client robust to support whatever interaction was required from web users towards the augmented reality users, their peers. So we started out with modeling on the completely on the front end and didn't concern ourselves with everything in between. However, there's a separate sort of discussion that I guess there's maybe time for later to discuss whether the state should be distributed in a way on the front end. We always think about, for example, in Redux as a single source of truth. I think that's sort of a misnomer, or at least a faulty way to approach state. I think state is by its nature distributed, both on the front end and between front and back end. And I think XState sort of drives you to that realization, to not work with Redux as your main state container, the one and only. This sort of divides up your state naturally via machines. I never thought about this as having single sources of truth or a single source of truth in my front end. That's one aspect of it. Then syncing state in my machine with backend, I think that's more of a generic issue, sort of not entirely dependent on what solution you pick. I was more concerned with modeling and making sure that my front-end state was placed at the right level of abstraction. So that's not an exact answer to your questions, but I think it's sort of outside the scope of XState and not entirely dependent on using XState as a library. I'd love to have that discussion though. Yeah. All right. My time is up, I guess.
It is. No panic though. Meris went to the bathroom, so feel free to do the same. And we'll let Meris start in a couple of minutes.
Cool.
But yeah, again, Mark, just that tiny demo of the button being disabled while you were fetching is
Without
such a
actually
good
being
way.
disabled, yeah.
Exactly. Yeah,
Yeah, yeah.
that really conveys the power of having this model power the app. Yeah, well done.
Thank
Great
you.
presentation. Thank you.
So main act coming up in a few minutes. There's still a tiny bit of time to powder your respective noses if you need to do that. And we'll pass the microphone on to Meris and Klyva in a very short while. And as Mark mentioned, we'll drop the link to his demo in the MalmöJS Slack, and maybe as a comment on the meetup page. Johan, do you want to say something about the Slack group? How does one join that?
Just ping us and we'll add you. So that's yeah.
That's the process.
Yeah. I don't think we have anything more formal than that. Maybe we should though. But,
Nah.
formal enough.
Yes. So Meris is back.
Yes, I am.
Shall we assume that everyone else is as well and give you the floor, Meris?
Sure. Sounds good. Let me just start sharing. Okay. Can you see my slide?
We can.
Yes, bold statement.
Okay, thanks. So yeah, I'm gonna talk a little bit about Klyva, my own state management solution for React, but I guess, yeah, state, not condition, as you said before. Okay, first a little bit about me. Meris Bahtijaragic. My mom already knew when I was 6 years old that I would become some kind of engineer. I didn't know what that was. First time I actually met a couple of engineers was in high school, where they came and visited our high school and showed us like geometric forms, how to transport milk and stuff like that. I wasn't really inspired back then, but then yeah, I did a lot of gaming and created my own games. So like when it came to decide what education I would pick, I found computer science, which was like yeah, feed two birds with one scone, to say so to say. Actually, I got to make my mom happy by becoming an engineer, but I got to play around with computers and hack all day. So that's what I did. Kind of parallel to that, I worked at the computer security startup for 5 years, and then they got bought up, and I worked at PriceBuy or Prisjakt for 9 months and got really acquainted with React and TypeScript and all that. And today I run my own LLC, Meris Code Consult, having fun with that. Enough about me. I just wanted to include this slide just to make it clear that Klyva really wasn't developed in any kind of a vacuum at all. I've just picked the most interesting parts about from others and like composed them into a small package. Just want to mention Redux toolkit. Like if you're me, you abandoned Redux way back and didn't ever look back. But now there's a thing called Redux toolkit, which kind of makes Redux actually good. So if you're forced to use Redux, or if you're going to force your team to use Redux, take a look at Redux toolkit. Also, the maintainer of Redux toolkit, Mark Eriksson, is a really cool guy, which makes long posts and talks about React and state management too. Take a look at that too. So Klyva kind of started from me looking at Jotai, which is an Atom-based state management library. I kind of tried to implement the concepts in just using Jotai, and I actually became a maintainer of Jotai while doing that. But it kind of had the right ideas, but it didn't have the right performance characteristics. So I created Klyva in parallel and kind of ported the Klyva concepts to Jotai, while Jotai was kind of catching up in those terms. Like it's a larger library with lots of more users. So yeah, if you don't want to use Klyva, but you want to use something like more, which you can trust more, made by the React Spring guys, use Jotai. Also, Daishi is really good. If you want to dig deep into state management, he's a good guy to follow on Twitter. Also, you can't mention Atom-based state management without mentioning Recoil.js. So my relation to Recoil.js is like super cool. They're the like OGs of Atom-based state management. But I was kind of recoiled by their tutorial. I actually didn't think, or yet until today, they don't actually represent themselves that well, honestly. I had taken a look at the tutorial and I was like, no, this doesn't make anything simpler. Anyways, so okay, that's out of the way. So a little back to Klyva. Like looking back now after working on this for like 6 months, it's kind of a Trojan horse of knowledge. It introduces a concept called functional optics. And that the way I was introduced to functional optics was like, I was reading a Reddit post where somebody asked, okay, I've read up on functional programming. I'm like done with category theory. I'm like super deep in. Where do I go next? What's like the next big thing in functional programming? And then like somebody said, oh, take a look at functional optics, or he said lenses, but lenses is part of functional optics. So ever since I read that, like 3 years ago, I've tried to like figure out, okay, how can I work functional optics? What is functional optics even? And how can I work it into my application? Also another thing, I think it simplifies state, Klyva. There isn't a huge API. The to-do app I'm going to demo is shorter, more readable, I think, than other state management solutions, and it kind of hijacks existing knowledge. So it doesn't like force you to wrap your React components in something, or like pushes a completely orthogonal kind of model to your React component dimension. Klyva actually like flows along with your React components, kind of becomes the React components. And yeah, I would recommend it for complex editor type applications. If you're like doing some kind of CAD work, or I don't know, kitchen planner or something like that, I think Klyva would be nice. I would still like, if you're doing data fetching, just use React Query, of course. Also, it gives you super good performance without having to like exploit use memo and memo too much, which is the reason I think that Klyva is like the reactive state that React never had. Okay, so let's move on to the API. Basically, in Klyva, an atom is like the state store for you. And you create it using the atom constructor, as you can see here. The value you send here is the initial state for the atom. And it returns an atom to you. And given an atom, you can get its current value. You can subscribe to all future changes of that value. And you can give it a update its value. So this this atom will be updated and all subscribers will be notified. So this is the whole Klyva API. I'm going to present 3 utilities that only build on these 3 things. So it's 2 hooks and just an ordinary function. But this, like, given these rules, you can implement a pretty good application. So, okay, let's move on. This is some code. So, as I showed you before, declare an atom, call it my atom with the initial state hello. And how do you actually use it in React world? You don't want to like do these kind of imperative function calls in React, or you can't do subscriptions really. So there's a utility which handles all of that called useAtom. And remember what I said about hijacking existing knowledge. So this looks like the return value of useAtom looks like the useState function, and that is done intentionally. So this useAtom actually subscribes to the myAtom atom. So if you have like a WebSocket or anything at all making changes to this atom, this component will be immediately, the changes will be reflected in this component. And yeah, I don't think like everybody should be pretty familiar with the useState API. And this is pretty much it, except it's like remote controlled state because the state actually resides here in the myAtom atom. Okay, and I promised you functional optics. So this is, I'm going to talk about the focus atom utility. So let's say that you have a atom which is big. Maybe you don't want to think about all the properties it has. You just want to focus on a smaller part. So I have my big atom here. It has 2 properties, count with a number and a name with a string. Let's say you want to create an atom to use in a component, but you don't want to care about all these other properties. You just want to, okay, give me a simpler perspective. I only want to care about the count. I want to render a count component. I shouldn't have to care about everything else in this big state. All this junk, I don't care. So for that utility, to make a pretend atom, which is only a number, you use the focus atom. First argument is the big atom. You send in an optic callback, and you use the optic prop constructor to focus in on the count property. Now, you might tell me like, but why aren't you using just the like value dot count, like object access thingy? Yes, that's a good question, because the point of optics really is to not only get a value in the read direction, i.e. just value dot count, but also get a setter for that property at the same time. You get that for free. You don't have to write all this dot 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 big value, etc., code. So okay, let's say we derive this counter atom. We can update it just because it contains a state, a number. Give it a number, then counter atom, its state is changed to be 10. At the same time, the big atom state is also changed to reflect this, because this is only a derived atom. It actually doesn't have its own state. It's just a focus on the big atom. Also, say that you update the big atom, say make the value count 20, get the counter atom's value that is also reflected. So it's like derived from in both ways. So, okay, we'll get to that. I'm gonna show some code later. Okay, and the last utility I'm gonna show today is use atom slice. So think of this as a utility where you wanna like render out a list of something like a counters or maybe a to-do list that you wanna render one component for each item in a list. So first of all, let's start with the like item component. So that's the counter component. This one looks kind of like this example. It just uses atom from an atom, but it takes, the big difference, I guess, is that it takes the count atom as a prop, and it uses it with the use atom function, and it creates a function to increment its count using the set count function, and it renders out the count and the on-click method on the button. But what's this here? Count atom.remove. That's a thing. There's a thing called removable atoms. Removable atoms are basically the same thing as normal atoms, except they have a remove method, which you can call. This kind of implies that they exist in some kind of list context, and they want to be, the user wants them to be removed from that list somehow. So we'll get into that soon. So how do we make our removable atoms and render out this counter for each item? Well, I promised a list. Here's a list. A list atom is an atom containing a list of 3 items. These are our counter states. So given our count list atom, we slice the list atom up into count atoms. We then map them as we all are used to in React. Map these count atoms out and give this counter component its count atom so it can subscribe to the atom's value, etc. So this count atoms is a list of atoms and this list of atoms is automatically subscribed to the length of this, to this list atom list. So if an item is added to the list atom list, to the list atom, then the count atoms gets another atom corresponding to that item. So yeah, let's, I think it would be better if we just started coding. So I'm just gonna switch over to this big view. Okay, let's start coding. So I've prepared this little app. I'm just gonna test. Hello demo. Okay, it works. So what I'm gonna do is kind of make a to-do demo application, because that's what like inspired me from the start, because Recall.js has a to-do application. So, but let's start with the to-do item component. And I'm thinking a to-do item should probably contain a task of some sort. Feed the dragon, be nice to animals, and maybe it's done or not. Let's say it's not done yet. Okay, so to do item. Let's say that this takes a to-do atom like this. And, just gonna do some inline typing here. String boolean. All right, to do atom. And let's use the use atom utility. So this gives us a to do and a set to do atom. Let's just render it as is, just to make sure things work. To do node. Oh, right. We have to give it a prop. Okay, so it looks like we're actually rendering this stuff out. Looks good. So let's make this kind of interactive. Let's make it possible for the user to like set the task. So let's use a input element for that. Use the platform. Type text, and the value is, let's do this. And everybody who's well, I think everybody who's done some kind of React has done this thing at some point. So this is nothing too weird, I hope. So let's set the to do to, we have a old value. Like this, and let's kind of try, yeah, looks like it's changing. Another thing that we can do, we can subscribe to this to any changes of the value like this. So let's just say I got a new value, and let's print the value out like this in the console. So let's say I add a exclamation mark it will be shown here because I'm logging it out, and I add a new one, and I'm spamming the console. So that looks cool. Yeah, let's do the same for the done property. So let's make it a checkbox, checked, and no, this should be done. Yeah, okay. So I made it true, and it is reflected here. Okay. So that's the first utility, use atom. Nothing weird with that. But I kind of don't like this thing, like ... blah, blah, blah. Here's the solution for that. So the problem comes from that the set to do is responsible for setting both the task part of the atom and the done part of the atom. That's why we have to like set the old value here. This is why optics were invented, because they let you get the value and the setter for the value at the same time. So let's make a atom which represents only the current task. So let's call it task atom. Let's derive it using the focus atom utility. Send in the to do atom, and as I showed you before, the optic callback. So optics have loads of methods, but today we're going to use a lens called the prop, or a lens constructed by the prop constructor. So as you can see, my autocomplete says, okay, we have two props in our atom. One is done and one is task. Can you guess which one we should pick here? Because we're creating a task atom. Yeah, that's right. We're gonna focus in on the task property. So this, as you can see, is just an atom of a string, while the to-do atom is an atom of a string and a boolean. So let's just use this atom instead. Task and set task. Use the task atom, and notice we don't have to do dot task anymore, because that's the objective of our optic. It already did it for us, like dot task. Awesome. So now we can do this. Yay, less code. And instead of doing set to do, we can just do set task. Target value. Remove all this code. Make it look, wow, so much shorter code. I like it. I didn't have to do all this stuff, which is kind of boring code, to be honest. I just say set task. It's like magic. And let's kind of do the same thing with the DOM property. So done atom, focus atom, but instead of focusing on the task, we focus on the done property. Done atom, is it done, and set done. So we can remove to do dot done and only have done. And instead of set to do, we do set done. Okay, no. Yeah, we still have like the old value, but yeah, we're just reflecting it to the target checked attribute. So now we have, okay. I'm just toggling it to make sure the global state is being mutated. So, okay, now we've kind of simplified our application. We don't have to do, we've discovered how you use an atom, you subscribe to its all future updates, and we've kind of explored the functional optics utility, which is focus atom, which lets us get a value and set a value. at the same time, which is pretty awesome. Now let's make this a list. So let's make a to-do list component. And instead of doing to-do atom here, let's make a to-do list atom instead. Can I turn this into a list of to-dos? And just to make it even more listy, we'll add multiple items in it. Let's say drink some water. Okay. So how do we map out this list? Okay, remember that I talked about a utility called use atom slice. So let's just get right into it and use that. To do items, to do item atoms maybe. To do list atom. Okay, so this turns our list of atoms, or no, atom containing a list into a list of atoms, or namely removable atoms. So if this list changes in size, or I guess cardinality, no, let's say size, then this atoms list would also change. So let's kind of map these out and give each to-do item atom to a to-do item component. To-do item atoms, map, to-do atom and index. I'm just saving the index to like please the React warning gods. Okay, bam. We simply reused our to-do item atom or to-do item component in a new context, i.e. this to-do list context, and it like still works as expected. I mean, well, if I now that I console log here, it's a list instead. But yeah, as you can see, the done property is true because I clicked here. So that's pretty cool, I think. But let's go back to this list. It's actually a list of removable atoms. But this only takes a atom as a prop. So let's just go along with this. And okay, I have to import this. Okay, TypeScript's happy. Now we have a removable atom. So what? And it seems to be like working as expected. Stuff is changing value as expected, etc. But this removable atom, it has a function called remove. So let's add that. Remove, or just X like this. But nothing happens because I haven't bound anything to it. So on click to do atom.remove. So keep an eye here. Bam. It's a list containing only one element now, and it's a list containing 0 elements. So all that code where you like are forced to write slice, blah, 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 that's already handled for you by just using the right abstraction, i.e. the removable atom. You don't have to do that. But okay, the obvious question here is like, how do we add a to-do item? Well, let's just give the user input where they can just write something and then press enter, and it's added to this to-do list atom state. Okay, I'm going to use some local state here. New atom and set new atom text. Okay, and we have a like create new atom. Well, maybe we should. Yeah. Okay. So let's on key press this, so you can press enter to create it, to add it to the list. So if they press enter, let's add it to the to-do list atom. Let's just use the update function. To-dos. Let's do this thing. New initialize a new to-do item, and let's clear this text, so it's cleared automatically. Set new atom text to just be like this. So hello, new item. Really short code to like be able to manipulate a to-do list, honestly. But okay, so we can add items, we can remove items. So why did I or use all these concepts? Why is it so important for me to like not have to bother with this? Remember that I talked about like an orthogonal tree of concerns of state. Why do we want to do it this way? So I'm just gonna go to the recoil.js documentation. Oh, I guess I can't. Oh yeah, okay. So let's kind of, I think it's good to compare code just to like realize, why are we applying these methods? What does it bring us really? So let's take a look at our to-do item component. So here's theirs. They also use some kind of input type text to get some, to print out some text and edit item text and all that. And also they do the delete item thingy. Oh, I really didn't realize it would look like exactly the same. We even use the same div element. Anyway, so this is from the recoil tutorial. Their equivalent to use atom is use recoil state, and to do list state is their equivalent of this to do list atom. So first of all, they're not sending the to do atom as a prop directly. They're sending the actual item, i.e., well, the value. Then what they're doing is they're subscribing to the big state, the whole list at the same time. Each item makes a subscription to all future changes of the to-do list. So when anything is changed in the list, really, all to-do items are changed. And what does happen then? And then it looks for its items index in this subscribed state. So it uses to-do list, find index of this item. And then they construct the edit item text, which is the kind of equivalent of set task, and toggle item completion, which is kind of the equivalent of set done, and delete item, which is like, yeah, you've all done this stuff before. So the idea behind Klyva is to like leverage optics to not have to write all this code, really. And like this code is also problematic because all these to-do items are like subscribed to the whole state. So you really can't get good performance using this method. I mean, this is really unfair because like this is a state management solution they're building. Like, of course, they will not have a good example of how to use it, but I kind of wanted to like try and make the to-do application shorter than conventional state managers. Also, another thing, using the profiler, we can notice that, well, okay, I'm recording, I'm just doing editing the to-do items, and we can notice that the other to-do item was never rendered during the whole profiling session. The to-do list wasn't even rendered, even though it's kind of subscribing to the to-do list atom. The only thing that actually rendered while I was pressing AAA was this component. You can see it's marked there. So that's another thing with Klyva. We haven't used any use memo. We haven't used memo either, but we're actually achieving pretty good performance. And that's why I'm saying that it's like the reactive state management that React never had. Yeah. I think that's it. I'm right on time. My 40 minutes are out. I don't think I have anything else to mention, really. Thank you for listening.
Thank you,
Thank
Meris. Woohoo. Meris, do you have that bigger performance demo within reach?
Of course, I always
with a big form. Because that's pretty impressive. I think you should show that off.
Yeah, like one of my objectives was to like, okay, I have this like completely unreasonable state. Like I call it a mega form. Let's see. Okay, so let me show you the JSON of the state. So it's like an object which contains multiple forms, which each form kind of contains a object, a key value mapping of a string to a string. So I want to make this super mega form be performant just using, well, use atom, focus atom, and use atom slice. Also a utility called use selector, but whatever. So let's take a look at how it behaves. So this was like the challenge for me. I really wanted it to be possible to like cleanly write an application where which is like unreasonable, like a huge form or whatever. That's easy to read. I mean, this field component. Let me show you it. So this is a field. So this part, the value, the name of the field, the value of the field, and the remove button. This is those two. Like it is so simple to write. Like, I mean, even if you didn't know what Klyva was, you know that this is a field. It takes some field, which is described by an atom of a string and a string, and takes a remove function. like this is actually readable code. It doesn't even imply that it's being used in a global context. It's just saying I'm controlled by an atom and I can control that atom using the update function. That's all it does. This is the reason I wrote my own state management library. So I wanted this to be super snappy. And yeah, okay. So what does this show? It shows that, okay, nothing else is being rendered in this whole application. The only thing that's being rendered is really this field. But also I want to show you the performance, like the actual milliseconds it takes to update this huge object. And I've also implemented the same concepts using Svelte and Jotai and all of that. Svelte is actually like it's called like cybernetically enhanced applications because it does all updates surgically. It's actually just 3 times faster than Klyva. So, which is like amazing because compared to like, if you had done this in set state, first of all, you wouldn't get the performance. Everything would be updating at the same time. Like it would be a mess of an application. You couldn't express the field atom or a field component like this. Like this is so elegant. But yeah, it's like super fast. 2.5 milliseconds for the React updating, which is super nice. Yeah, that was like I still use. I have an example where I do this with Jotai, and I get like, okay, Jotai is maybe it takes like 8 milliseconds or whatever, and I have to be a little bit use some performance optimizations, use memo, but it's pretty good as well, right? It's just a factor of 2 or 3 slower. So Jotai is also usable. You won't notice a difference between 2 milliseconds and 8 milliseconds in your application, really.
But the big difference is, like you said, Meris, that, okay, so with Jotai, you as a developer would have to be proactive and use memo, while when you do Klyva code, you don't have to care. You get that for free.
Definitely. Klyva is like optimized for these unreasonable expectations of developers. Like, I don't want to use memo. Give me something that I can do. Like, yeah, that's like, I think that requirement kind of drives creativity. Like, it forces you to like look up and find solutions. So yeah.
That is impressive.
Nice presentation, nice library and abstractions. But I have a few questions.
Sure.
So in Recall, you do have selectors to derive state or data.
Yeah.
How do they differ from your focus atom abstraction?
So selectors are only one way. They're only read only. So like if you did a selector on the count property, it would just be for the read direction. It wouldn't actually give you the setter for the count property, and it wouldn't like neatly package it up into like just another atom. It's
right.
not. Yeah,
but it does allow me to be very specific on what I actually want to subscribe to and what gets updated, right? So you're packaging something more neatly for me to use. That's actually good. Yeah. And I was also wondering about the React memo specifically.
Yeah. So
I sort of get to use memo, or obviating the need for use memo, but I don't get when and where you skip React.memo. Well, if you're rendering a list of atoms and you actually remove an element from the slice, you still have to re-render all your to-do items. Why would React memo not be useful in that regard?
Okay, you got me there. So in that instance, that's like that's the instance where yes, the to-do list component would have to re-render because it would map out a different set of children. But that's only when the size changes. So the way you would like skip using React.memo would be for the case where just an item's value is changed itself. So not the length of the list. But yeah, that's a good point. Also, I kind of designed use atom slice to give stable references. So if you want to like keep this behavior where the atoms themselves aren't re-rendered once the list changes, then that's done for free, basically, by keeping the atom references, memory references stable.
That was my follow-up question. Are they identical between re-renders? And I was hoping you would say yes. So yeah.
Yes.
That's good. Awesome.
Yeah.
Great work.
Thanks a lot. And one thing that I was always doubting myself, even when like actually proving it for myself. But one thing that like really validated it for me and meant really much was when David, he made a to-do MVC application, which exists in the source tree of Klyva in the examples folder. So if you're interested in a little bit more advanced example, please take a look there as well.
I have a question on React's future when they do concurrency mode and all that stuff. Is that supported, or how will that go?
Okay, thank you first of all for asking this. This is something that I think. Remember that I mentioned Mark Eriksson, the maintainer of Redux Toolkit. He has done a lot of talks or articles and tweets about this. So definitely check him out. He also did a talk about when they tried to fix Redux so that it's CM, I mean concurrent mode React compatible, and their performance just went to hell. So they're kind of re-evaluating. I mean, what's good about CM? The best thing about CM, you know what that is? It's that it isn't released yet. So that's the absolute best thing about, because it will unleash hell. Because if you're wondering about like, if you're aware that like these super smart people, Mark Eriksson and company are worrying about concurrent mode, then like think about your own code, all the applications that you have written. Like I'm not sure that any custom hook that I've written or any usage of React that I've done lately is concurrent mode compatible. But okay, I kind of digress. This is a fun subject for me. So there's this theoretical problem called tearing that might occur in React concurrent mode. There's a talk, like I said, about from Mark Eriksson and Flarney. So it does like some simulation, like there are 9 tests to like assert good behavior in concurrent mode. And this repository contains like a table of all imaginable React state management solutions and like how they pass the like tearing tests. Okay, are you ready? Okay, here are the results. you can see there's barely any that actually pass all tests. I mean, take a look at React Redux. Yeah, doesn't look too good. By the way, this is Daishi. He did this. He's one of those that I mentioned in the start. He made this repository. I also added Klyva here. Jotai is here as well. It behaves pretty good, only missing test number 7. And Recoil, which was like, I think they mentioned that they are concurrent mode compatible. They aren't, according to this test, current mode compatible. But I guess, like as I told you before, it's like a future. It's not out yet. There's stuff to happen before it is released. But I don't know if this answers your question, but here's like the state of the React ecosystem summarized in one table.
Yeah, it's pretty cool to see. I mean, obviously, very, very nice to know that's you're thinking about it. I mean, if I were to use it in a customer's application or something, that's pretty cool. Nice.
Yeah, and there are a couple of like ugly hacks that you could do to like avoid the tearing issues, and that's like the worst case would be called de-optimizing in to synchronous mode for these kind of updates, and there are theoretically solutions out there made by the React team that one could use as a last resort, but like it's a de-optimization. So it's kind of removes the purpose, I guess, of concurrent mode. Like I shouldn't talk about this too much because I know that like eventually I will be wrong. There's no certainties that you could say about this. Like, yeah, I have some concurrent mode anxiety, but I think we'll be fine.
That's a very good final note.
Meris, can I ask one more question? Is there time?
Absolutely. Or yeah, David.
Yes.
How do you like internally keep track of all the atoms and all the what is the mechanism you use inside Klyva to keep track of all the I guess what do you call them, subscriptions?
So like the state of the atom is like each atom that you create contains its own actual state. So when you do the like atom constructor and you declare it somewhere outside your React component tree, that's where the state is stored. It's like stored in the variable. So but you could like theoretically put in React context and like access it from React context or whatever. There's another interpretation of your question as well, and that's like implementation wise. I originally used RxJS behavior subjects for my internal streams or internal representations of the atoms. I got like an 8x performance boost or something like that from in the Megaform application by just skipping RxJS and just using something called a stream implementation or a stream implementation protocol called callbacks David is responsible for me knowing about, at least.
Cool. So like because I figured like when you have the global state and you derive the state from it, you somehow have to like they're connected. So but that's then done with callbacks.
Exactly.
Maybe David can do a presentation about callbacks at some point.
That's been on the list, me or someone, but it's definitely worth talking about. It's a fascinating thing. Yeah.
Another question I had is it possible to pass the optic callback as a second argument to the use atom hook? So you can skip the deriving the atom. You can just do it in one line.
Okay. I think I understand. I'm just gonna go back to this thing. So let's go back to the field example.
Yeah, that one. So you can fold 23 and 24 in one line.
Oh, you mean like?
Well, no, more like that. I guess like focus atom. Okay, yeah. Yeah. Okay.
You mean like?
Like past that second thing. Yeah, there. Yeah. I was thinking, is this a possible way to make it
Should
denser?
make a PR, Elke.
Yeah, send a PR. Yeah.
But yeah.
I guess like there's nothing technically stopping from that happening. The reason, well, technically there's nothing stopping. That's super possible. But the reason I did not do it was to like give people a false impression that this is super simple. So I wanted to like, okay, I can introduce use atom as its own concept and focus atom as a like separate concept, so that people like are, I don't know, it just feels like people would think it's easier to understand if I separate those two concepts, right?
Are there other functions like focus atom, or is focus atom one of its kind of? Like there's not like focus atom and like derive atom and blah 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 atom. It's just like there's just focus atom and you pass an optic callback and then it gives you a new atom. That's maybe a weird question. I was just wondering how big the API service is, and maybe that's why you want to have it split out as well, because
I guess so. Like, yeah, definitely.
okay.
Cool. You've shown the entire API, Meris, right?
Yeah, that's truth with a little bit of modification.
Almost, yeah.
Yeah, I guess there's an explicit thing called derived atoms where you can like derive. It's like a Redux selector, but for values and like automatic subscriptions of atoms. Actually, it's just confusing if I talk about it. Let's show how. Let me show you how it looks. So let's say I have user ID atom, which is just a number, and user name atom, which is Meris. So I can derive an atom which kind of subscribes to both of these atoms. So user atom, I guess. Oh, well, ID and name. So this is a atom of a number, and this is an atom of a string, and this would just be like a read-only atom. I call them a readable atom. The only difference between a normal atom and a readable atom is that they only have the like readable functions, get value and subscribe. So that's another part of the API that I didn't mention really. Yeah. So it kind of, so it's a way to like in globally declare an atom which is just derived from the values of two atoms, which is updated when like one of these two atoms updates, or both of them update, then the value that's returned from this atom is also updated at the same time.
I have another question. So
Sure.
you use an sorry, I'm like whispering because my wife is sleeping. So you use like this function optics library, right? An existing one. You only gave an example of the prop.
Yes.
But yes, you don't have to whisper. And so can you give some examples of other optics, like other examples, not just the prop one, but maybe some other things you could do? But...
Okay, so there's this library. The library I actually use is called optics.ts. I'm responsible for, I think, more than half of the issues reported in the repository. But like, honestly, if you want to learn optics, this is, I think, the best resource I've ever encountered, because this actually, I don't know, I've tried to learn optics in many ways, but this, like, reading this documentation was like the only way that like actually did something to my brain, that made it understandable. So there are quite a few optics, and as I told you, like path prop is one optic which lets you like focus on a property of an object. It's called a lens, because a lens just gives you the value of type A and a setter of A. There are other kinds of optics. For example, index optic. It's when you want to get the index of an array, an item in an array. So let's say that we have this to-do list atom, and I want to focus on the
first one.
Yeah, let's say optic index 1. So this gives you to do an atom which focuses on the first to do, and it gives you, I call this a prism atom, because, and here's the reason why it's called a prism and not just an atom, because okay, because this is completely type safe. It gives you a value which is a task of a string, a done of a Boolean, or it can be undefined. This is what makes it a prism, because the value might not exist, like the item at index 1 might not exist. Reason it is a prism is because the update function, notice that the updater doesn't say that it can be undefined. The updater doesn't care if the item is undefined. The only thing that happens in the updater is that if you try to update it and it's undefined, then the list simply isn't modified. It's completely unchanged. So that's like the difference between a prism and a lens. A lens is when we just focus using a property. A prism is like, it handles the case where the item doesn't exist. So I've explained lenses, or let's pretend I explained lenses. I've explained prisms. There is only one more type of optic actually, and that is a traversal. Also, I kind of lied. There's lenses, there's prisms, traversals, but there's like the read-only versions of them. A lens read-only lens is just a getter. Read-only prism is, and this is not like as obviously named as a getter. It's an affine fold. Never mind that. And the traversal is like, it's the same thing as a prism, but it, instead of being an item of type A or undefined, it's just a list of type A, or a list of type A. And the setter is just a setter of type A, not a setter of a list of type A. Anyway, those are like, if you want to learn optics, those are like the three ones to learn. Isomorphic is like, it's a two-way transformation. Imagine like you're doing object dot entries on something. That's the first way of, that's like one transformation of an object. And then how do you transform it back? You use object dot from entries. So that's like a lens which allows you to get a isomorphic view of an object or a state. I'm gonna let each person that wants to explore the like deeper explore lenses do it. I think reading the optics.ts repository is good. I use some kind of more advanced optics here, like in the Megaform application, where I actually use the ISO optic to like transform. I'm not gonna say this whole type signature, but it's transformed into a way that I can then handle the data. Like it's a way to transform your data into a way that makes it easier for you to handle it. Like you take the data to an imagination world where it's easier for you to handle it. Yeah.
So instead of like projecting the actual values, you have this predefined API using optics to map your data that goes a bit further than just map and reduce and entries, and has like very specific transformations that to go in both directions.
Yeah, exactly. I think the thing about optics is like it's always in both directions. That's like the important takeaway. Because if it was only in the read direction, then you could just use a function that maps a thing.
So I guess like the only issue with this is that everybody needs a PhD on your front-end team.
If I may answer that, Meris, the main takeaway with Klyva from me has been exactly what you said before, that you get with optics, even if you don't understand it, you can easily derive a child optic from or child atom from a bigger atom. Like you had the to-do item and you focus on the input and you get the setter for free. Even if you only learn that is such a huge boon. It's really weird. Like just trying out new JavaScript state management solutions has been a favorite pastime of mine for years. And just this super common situation of you have a smart parent component that owns a big chunk of state, and you need to pass some of that state to many children. And each child has to then have a use callback thing to notify the parent, and you have to ensure that it's the same reference function, that it doesn't re-render. And then in the parent, when you handle the change from the child, you have to do ... and splice, as Meris said before. But here you don't do anything like that. The parent just has the big atom, and then it sends derived child atoms to the children. And this pattern is really easy to learn. You have to learn the word atom, which is a bit scary. But once you've done that and accept the pattern of passing atoms to your children, that's it. Like 35% of the code goes away. It's one of the most elegant APIs just for this super mundane state handling that I've come across. I'm really impressed. And then on top of that, you have the performance discussion and the rest of the optics stuff. But that's where the PhD comes in, as you said. And I'm not there. So yeah, 9:15. I guess we should wrap things up. Unless anyone has a pressing last question. Thank you all for coming. As we said, we don't have a date for or a subject for an upcoming meetup yet, but hopefully something will turn up. And again, if you feel you have something to say or something you want to hear about, then please reach out.
Thank you all. It's been great.
Thank you.
Maybe we can post some of these links that have been posted in the chat to the Slack group as well.
Yep, and to the meetup page probably as comments.
Yeah, that would be great.
We'll make that happen. Thanks a lot, guys.
Awesome.
Cheers.
Thank you, everybody.
Thank you.
Thank
Bye.
you.
Take care.
Both of you.
Here. Start my repo.
Do that. Bye.